Hello and welcome everyone to this first live broadcast hosted by the EMEA H2O.ai team. My name is Ivan Trehin and I am on the marketing team here at H2O.ai. I am here today with John Spooner, EMEA Head of Artificial Intelligence at H2O.ai, and Harib Bakhshi, Lead Data Scientists for the UK at H2O.ai. Today, John and Harib are going to discuss the challenges and benefits of automatic machine learning. And this will be a conversation between them, but also with you. So please enter your questions into the comments section and they will answer them during this live session. John and Harib, over to you.
Excellent. Thanks for that. Hi, everyone. My name's John Spooner and I'm the Director of Solution Engineering here at H2O. I've got a fair amount of experience in this particular topic of data science and AI because I've been in this industry for over 2 decades. I've seen some fantastic advancements in this particular technology, and it's going to be great to talk to yourselves and also Harib about some of the latest evolutions that we're seeing with regards to AutoML. So Harib, can you introduce yourself as well?
Yes, thanks, John. Hi, everyone. My name's Harib Bakhshi. As Ivan said, I'm the lead data scientist for the UK and Ireland at H2O.ai. And I've been working as a data scientist for the last 6 or 7 years, and prior to that came from a maths background at academia. And at H2O, I've been helping our customers adopt AutoML and helping them work with H2O technologies.
Awesome stuff. And it's already good to see so many people on this particular live event. Do feel free to ask particular questions through the LinkedIn channel. So today we're going to be specifically talking about the whole topic of AutoML, its challenges, and also its benefits as well. And that really leads us on to that first point of what is AutoML? I'm pretty sure AutoML to our audience means so many different things. So Harib, what would you say is your definition of AutoML?
Yeah, and it's a good place to start. There tends to be a lot of ambiguity in the terminology that gets used in the industry. If we think about AutoML, AutoML stands for automated machine learning. And really what it's looking to do is, if we consider the machine learning process and everything it takes to build a machine learning model, AutoML is trying to automate as much of that process as possible. It's looking at areas where there's repeated work. It's looking at how certain parts of that process can be enhanced to make the data scientist more effective. And if we look at H2O, H2O has really been focused on AutoML. That's really been our primary focus. And for those of the people in the audience who might not have heard of H2O, can you talk a bit about H2O, John?
Yeah, so H2O, we've been around for since 2012, really looking to see how we can really revolutionize the machine learning space. And AutoML, as you rightly say, Harib, is something where it allows us to accelerate some of that data science process. I think one of the questions that I've got for yourself, Harib, and sort of linking it back to some of the questions that are coming through already, is can AutoML help with NLP? Do you think so? Natural language processing.
Yeah, and it's a really good question. So if we look at AutoML and the different vendors who produce AutoML software, there's a lot of variety between what different vendors are focused on. So if we look at H2O's AutoML software, and we talk about our enterprise offering driverless AI, that can now work with NLP data. So if you've got any textual data in any of your features, they don't have to be numeric. The AutoML framework will actually go and extract features from that textual data using techniques such as word embeddings. So actually, if we look at AutoML, it's actually evolved quite a lot back from just being able to work with numeric data. And these days it can do quite a lot of fancy stuff with NLP data as well.
Yeah, and I think that's a really good point, because a lot of the advancements, especially over the last couple of years, has been to look at different data sources. So structured data, numerical data, or even character data can be analyzed using AutoML techniques. You've touched upon the textual data using NLP, but I think there's also the other point as well with regards to image data as well. I was having a conversation just this morning with a customer, and if we think about image data, it's still very structured in its nature. It's just very big. It's still basically at the heart of it. It's just ones and zeros, maybe with a few nuances on that. But so yeah, AutoML can help in all of those different areas. But I've been working, as I said, in this whole space since leaving uni, which was many years ago. But I would say that people were still doing this type of work even back then. It just wasn't called machine learning. It's a lot of this machine learning has got its roots in statistical modeling. So where do you see, Harib, why have we got such a big interest in this now?
Well, I think there's a few reasons for it. I think if we look at the role of a data scientist, I remember I spoke to someone a while ago who said that a data scientist is just a statistician with marketing rebranding all over it. And if we think about what a data scientist does with machine learning and the maths that gets used in the back end, it's old maths. It's not like these things.
So you're saying that we haven't discovered some new maths then?
There's constant slight improvements, but I think the fundamentals of what's being done, it's the same old maths. The big difference that we have is the serious reduction in compute cost. It's much cheaper to have very powerful computers to process those calculations. And then it's the kind of techniques that we use to handle those different data sets. So as we've touched on, being able to not just work with numeric data, but textual data, image data, it's those things that have really brought this excitement around machine learning and AI.
Okay, and we've talked about obviously the different types of data, but the data sources that we're talking about, textual data, image data, even when we're looking at transactional data from a structure perspective, that can be fairly large. We're talking potentially petabytes worth of data. So one of the questions that I can see is come in is, well, is this efficient and is it scalable on large amounts of data? Would you say that it is scalable?
I would say that it is scalable, but it depends on the kind of AutoML that you're doing. So it's important about finding the right solution for the kind of problem that you're working on. So if you're tackling an AutoML problem and you just have vast amount of data, there's a few different ways that you can handle it. It may be that sampling that data is sufficient, and as part of the AutoML process, it could consider options like that. But it could also be that AutoML can work in a distributed environment. So if we look at one of the products H2O has, sparkling water, that allows you to run AutoML in a big data Spark environment. So there is now frameworks in place to allow you to scale up any AutoML that you're doing.
Okay, so distribute that apart across a massive compute cluster.
Yeah, exactly.
Okay, and that's really important, not just for large data volumes, but also the complicated maths. So such as neural networks, for example. So how sophisticated would you say we needed to be to do this AutoML? And this links to one of the comments that came in to say, can we recommend a beginner to learn AutoML before using sklearn, for example?
Yeah, that's a really interesting question. So if we look at what H2O does, one of our goals is to try and democratize AI. It's trying to make AI more accessible to others. So certain vendors, when they're producing AutoML, it's all about eliminating the need for data scientists. Actually, I think AutoML can help in two ways. So I envision there being two types of users. There's the almost citizen data scientist who doesn't necessarily have the deep data science understanding and background. And certain AutoML solutions should allow him to be able to build relatively simple models without worrying too much about what's going on under the hood. A lot of AutoML solutions such as H2O's also have a number of safety checks. So that means that your less experienced data scientists can build models without actually accidentally doing things like overfitting or having leakage in their data. So I think AutoML can allow your non-typical data scientist to build some models. It really depends on the kind of solution that's being used. It can also be quite useful because of the explainability part of AutoML, actually being able to provide explanations for how that model works. Your non-experienced users who are using AutoML, they may find that understanding those explanations really helps them understand what's happened under the hood and the kind of model that's been built.
So really, it seems that term AutoML has started to expand over time, because if I think back even just 5 years ago, AutoML was very much pigeonholed to how do we select the best algorithm? And then it started to grow to say, well, how do we also automate the process of working out the best algorithm and the structure of that algorithm using hyperparameterization? Then it expanded again of automated feature engineering. And now what you're saying is it seems to have expanded again to also look at how can we automate the process of explaining the inner workings of that machine learning model itself as well. And I think would you agree with that?
Yeah, no, that's right. And I think we're definitely starting to move into that end-to-end process. It's understanding that the data scientists, they're not spending that much time actually just tuning those machine learning models. A large percent of their time is trying to engineer new features, trying to extract new bits of information that are going to be predictive in their nature. And actually AutoML started to help with that. So the feature engineering side, as you said, we came into that space a while ago, and that's really been driving a lot of the improvements in accuracy. It's those features that are being engineered as opposed to the models itself. But actually getting the organization to adopt the technology, you need those explanations. You need the ability to be able to explain those models, allow people to actually understand how those models are making the decision. And I think AutoML can really help with some of those problems now.
And I think there's always a concern that, especially when presenting an automation process, it's about, well, how do we then take away the role of a data scientist? The way that I really see it is we are just touching the surface of the types of problems that can be solved using machine learning. And there's just not enough talent in the world and not enough productivity being generated by that talent to help solve all of those problems using ML. So having steps that allow us to automate the boring part of data science, I think really adds to this as a job function. So we've already talked about how we think AutoML can be helped from it to make data science quicker. But one thing that we haven't talked about is how do we deploy the results? Do you think it's possible to automate the deployment of the results that come out of an AutoML process?
Yeah, it certainly is. And there's a few things to touch on there. So one of the big problems that organizations have that we've seen time and time again is actually once they've built that model, which can be a time-consuming process on its own, is actually how do we get that model in the production environment where the business can access it and it's secure, latency requirements are being met. And actually having AutoML can really help with this because it allows you to do a few things. The first thing is it adds some standardization to that process. Every model can be deployed in the same format and in the same way. And actually, if we look at AutoML solutions like what H2O is doing, any model can be exported as a single Java object. That single Java object can be deployed in any programming environment. It hasn't got a dependency on it being Linux or Windows or R or Python, and it can really help by providing that kind of flexible deployment option. So AutoML, I think, is really helping with deployment.
But do you still need to have H2O running in that deployment environment, though?
No, you don't. So any model that gets built with H2O, you could export it into any programming environment, and it wouldn't have a dependency on having H2O running elsewhere. It would run standalone in a very low latency and lightweight fashion.
Okay, so that really opens up the possibility of then using this to deploy machine learning models directly to maybe IoT devices. For example. Okay, that's really interesting. What I've seen from a cloud perspective, and that's really opening up new possibilities, not just the fact that we can massively scale across machines, but also the exploitation of GPUs. Do you see that at all happening with conversations with your customers?
Yeah, that's certainly something that I'm seeing with customers more often and more often is customers, when they're adopting AutoML, they want to get to the answer as quickly as possible. And that's one of the things that AutoML really helps with. But as part of getting to that answer as quickly as possible, it's about utilizing the best hardware as possible to get to that answer. And actually utilizing GPUs in the back end to train those models can really accelerate the amount of time it takes for the model to train. So I'm seeing most of our customers now are starting to use H2O's products, where all the algorithms are built to support that GPU. They really are tending to use GPU servers for most of their AutoML models, and it really is accelerating the time it takes for them to build those models.
Okay, so we've seen that AutoML can be really good to accelerate the process. We also can be seeing that AutoML could give a higher level of accuracy. This really sounds a little bit too good to be true. So as a data scientist, both you and I, just by our very training, have been trained to be open-minded and also pessimistic at the same time point. So there must be some challenges and pitfalls with regards to this. It's probably not a case of, well, it isn't a case of, here's some data, throw AutoML at it and all the problems go away. So let's have a chat maybe about some of those challenges and pitfalls. Clearly, one of the things that drives machine learning is the data. So what challenges are there, do we think, about data itself? What do we need to drive that?
Yeah, there's a number of challenges when it comes to the data itself. So one of the first requirements that you're going to have, and it's a requirement you're going to have with most machine learning, is that you need a lot of high quality label data. And that data needs to be in
Can that one, I just actually pause you on that one, only because it links into a question that came in from someone from MasterCard, which is, how would unsupervised learning fit into AutoML? Because what we're saying is that we need high quality labeled data. So I'm just thinking, would unsupervised learning fit into the AutoML space then?
Yeah, so and it's a good question. So if we look at the different types of problem in machine learning, you have your supervised machine learning problems and your unsupervised machine learning problems. And AutoML has gotten quite good at working with those supervised machine learning problems. But when we're talking about that unsupervised learning, where we're looking to cluster some unlabeled data and add those labels onto it, AutoML can help with that as well. So if we look at H2O3's open source, which is accessible, anyone can access that. You can run that in an R or Python environment, and you'll see that the H2O3 AutoML will help produce unsupervised learning models as well as the supervised learning models. So that's definitely a capability that exists today.
I think one of the challenges that you have with unsupervised learning, though, is that you don't have a ground truth. So what you're trying to do is to put people into groups based on that data, but whether or not you put people into 6 groups, 8 groups, 20 groups, 26 groups, there's sort of no right or wrong answer with unsupervised learning. And I think that's one of the challenges you face with, yes, you can automate the process of putting people into groups, but how do you know if that's the right answer? What's great about supervised learning and the high quality labeled data that you talked about is that you know and we'll probably touch on this in a minute, is you know the ground truth. You know whether something happened or you know whether something didn't happen. And what you're trying to do is to work out what the characteristics are to drive that. In terms of, I think also if we think about AutoML, there's a real danger, I would imagine, of getting into a point where we don't have any human control in this process, which probably causes issues in highly regulated industries such as finance or healthcare. What are your views on that?
Sorry, John, you spoke up for a sec. Could you repeat that last bit?
Oh, I was just going to say, so the problem that we have in maybe AutoML is that there's no human control at all. So that could cause issues with financial services or healthcare where it's in a highly regulated industry. So how could we get around that?
Yeah, that's certainly a challenge. So one of the things that I've seen organizations do before is when they start first adopting the technology of AutoML and they start getting a lot of value from it, they very quickly want to move towards an almost model factory system where they have loads of models being automatically trained, put into a production environment, and everything happening in an automated fashion. And the problem that you have with that, there's a couple of things. The first thing is that if you're constantly retraining that model in a live environment, but it's being done in an automated fashion, the actual training data that it's learning from could have changed. The business problem could have slightly changed. And by constantly retraining that model and naively putting it into production without that human control, you might not have that awareness. And the second thing comes on to what you're saying with when it comes to regulated industries, it's that accountability. It's if these machine learning models are making automated decisions on a daily basis, who's accountable for that? And actually having some manual checkpoints where humans have to intervene and sign off on parts of the process can have that, add that accountability and help with that regulation and governance.
Okay. One of the things that it'd be really good to drill into, sort of from the data perspective, going into AutoML, is the model that is generated out of this particular process is only as good as the data that went into it. And I'd imagine that there's a huge bias potentially of these machine learning models with regards to the data that feeds it. Are you seeing examples of this? And if so, what checks organizations making with regards to that?
Yeah, it's this is an area of growing concern in the industry at the moment, is these models and any bias that they may have when they're making their decisions. So I'm sure a lot of people have seen instances of where AI has failed. You've seen instances of where companies have used automated systems to decide on hiring, who they should hire. And actually, it's really important that we understand any bias or discrimination that exists within our models. So any machine learning model that we built that is making those kind of decisions on a daily basis, we need to make sure that they aren't looking at uncontrollable factors. So things such as race or age or gender. And actually, there exist techniques embedded within H2O, for example, such as disparate impact analysis, that can allow you to test for the impact that these features are having on your model after they've been built, effectively allowing you to test if the model that you've built is fair. And actually, testing if that model is fair is a really important thing, because if the model turns out to not be fair, it's likely an indication that there's some bias that exists in your training data, as opposed to the model just discriminating in itself. So actually doing those tests for things such as disparate impact analysis can really help to make sure that your model's acting fairly against certain factors.
Okay, and that sort of brings me on to that next topic, or onto something that someone said to me probably about 6 months ago. They said, "John, we know our model is fair." And I said, "Oh, how do you know that?" And they went, "Well, we don't put those discriminating factors into our model." I said, "What do you mean by that?" And they said, "Well, we don't put someone's gender in as a feature, and we don't put someone's ethnicity into the model. We don't put in their sexual orientation into the model. So therefore, the model is not biased towards those features." Clearly, I said to them, well, that isn't a way to stop your model being biased. Would you agree with that?
Yeah, I would definitely agree with that. And this is a really common misconception where people think, well, I don't want my model to discriminate on age or gender, so I'm not going to put those features in my training data. But actually, given the complexity of these models, they're able to pick up certain patterns in your data, such as looking at the name of the person, and they can use those as a proxy to figure out what their gender could be or what their age could be. So actually simply excluding that information and saying, well, my model can't discriminate against age because age isn't in the data, it's not enough. It's important that we use these techniques to look at the impact that those features are having.
So to do that after the model was being built, to check that we haven't got that bias based on any protected characteristic that we have.
Exactly.
Okay. And I'd imagine that's where a lot of the data science work then comes, to do those double checking and triple checking. Cool. The challenge that I see with AutoML is the fact that we have to deal with real data. And what I mean by that is we're going to have data that's missing. We're going to have outlying values. With that, a lot of data scientists go, well, AutoML can't handle with that. Would you say? I think that's a misconception. Do you agree?
Yeah, I agree that is a misconception. So often people who have been working in this data science space have been building these models. They have this conception that if the data is not perfectly clean, if there's any missing values, if some of those distributions are skewed, or if there's outliers, AutoML is not going to work. Sometimes they say they may not have enough data, or the data may be too varied. Actually, what we tend to find is that if you can use machine learning on that use case, then most of the time AutoML can help with that as well. Maybe the top 10% of machine learning models that data scientists build that are very heavily specialized and quite bespoke, those ones it's best to do manual, but the rest of them I can see AutoML playing into that and helping with those issues.
Awesome. Well, we're coming. We just had a 30-minute slot, so we're coming to the end of that. So we've got three minutes just to finish off. I think one of the things that'd be really good for the audience to know is, if I'm a data scientist or an organization getting started in this, what's the best way to do this? And also, how can they get started with H2O?
Mm-hmm. Yeah, so it's a good question. So the first thing to say is that you need to understand what your AutoML requirements are. What is it that you're trying to achieve? What are the business problems that you're currently facing? And often some of the first few questions to ask are things like, how flexible is the platform that you're going to use? Is it going to easily be able to integrate with your existing systems and processes? When you want to deploy those models and when you want to actually train those models, how easily is that software going to work with your environments? And then actually the types of machine learning that you're doing. Are you doing a lot of unsupervised or supervised or time series modeling? It's really important to consider all of these questions when you're picking a vendor. And if you're looking to just get started and you're looking to get started with H2O, there's a few options that you have. So the first option is you can use our open source, H2O3 open source, which works on R or Python and really helps data scientists train that model and do the hyperparameterization of that model. But you could also request a free trial for Driverless AI, which is our enterprise offering. And Driverless AI does the end-to-end AutoML process, everything from cleaning that data, engineering those features, training the model, and then providing some explainability and deployment options. And if you want to get started with Driverless AI, but you might not have the right environment to load it up straight away, you can actually go on a website called aquarium.h2o.ai. And that will allow you to try Driverless AI on our servers, just so that you can give it a go and see what you think.
Okay, and that links nicely to one of the questions that I see on LinkedIn of giving guidance for learning H2O. That Aquarium website, aquarium.h2o.ai, there's some fantastic tutorials on there, both from an open source and the Driverless AI product that people can then utilize.
Yeah.
So I know we've gone through this at quite a rapid speed. Thank you everyone who's been online asking questions. As with anything, and we get a large audience, going through all of these questions has been hard. Hopefully we've been able to cover most of that. There has been some technical questions coming through. While both Harib and I are technical, probably if you could go to our website to ask those specific technical questions, then someone will get back to you on those and help you solve those. So Harib, any last thoughts from yourself before we welcome back Ivan?
I think it's been a really great session. The only thing that I would add is if people are interested in learning H2O, you can also access training.h2o.ai. We have some training courses. And yeah, thank you very much for the questions. And hopefully we'll be able to do another session soon and answer some more.
Yeah, and I would just echo all of those comments. And for those of you that have enjoyed this, feel free to put some comments with regards to future topics that you would like myself and all of the H2O team to talk about. So, Ivan, do you want to say some words?
Yes. Well, thank you, John and Harib, for this great session. And thank you to everyone who attended. Feel free to reach out to us if you have any other question. We'll be happy to continue the conversation. And thanks, everyone. Have a good day.
Take care. Bye.
Thank you.